Hello guys. Okay, so when the reactive forces or the internal forces over a cross-section exceed the number of independent equations of equilibrium, the structure is called statically indeterminate. So these cases require the use of additional relations that depend on the elastic deformation in the members. So to understand this these statements very well, let us have a problem. The first problem, 400 millimeter by 450 millimeter concrete column is reinforced with 625 millimeter diameter steel bars. It carries a compressive load of 350 kilonewtons. Determine the stress in the concrete and steel. Use elasticity of concrete equivalent to 15 gigapascal and the elasticity of steel equivalent to 200 gigapascal. So this is an example of say we have a home. You have a home, okay, a simple cross section of a home supported with a column, and this particular column has this kind of dimension. It has 400 by 450 dimension. It has a certain height, okay, and this column, which is 450 millimeters, 450 millimeters by 400 millimeters, has 25 millimeters steel bars. So you have 1, 2, 3, 4, 5, 6. So in your concrete column, so the elevation looks something like this. Okay, so it carries a load of 350 kilonewtons, and that load of 350 kilonewtons is counteracted by your concrete and by your steel. So we have here the steel reinforcements, you have there the steel reinforcement, so it is also counteracted by your steel. So the red ink represents your force of the steel. So the first equation of equilibrium, summation of forces vertical, you would notice that the force of your steel plus the force of the concrete plus the force of the concrete is equivalent to your 350 newtons. This is your first equation. Okay, it represents the equation of equilibrium, summation of force vertical. So that is your equation number 1. Equation number 1. The second equation is that when this column is pushed, it's going to deform. So magkakaroon siya ng settlement, and that settlement is a little deformation. So both the concrete and the steel will deform. So therefore, the deformation of your concrete will also be equal to the deformation of your steel. This will be your second equation. This is your equation number 2, and you know that the deformation formula is equivalent to force times your length all over your area, all over your elasticity. Okay, so this is your equation for elastic deformation, and this is your equilibrium equation. So if you're going to combine these two, you would now have this equation for first the deformation for concrete equivalent to the deformation for steel. You have the force of the concrete multiplied by the length of your concrete all over the area of your concrete divided by the elasticity of your concrete should be equivalent to the force carried by your steel, length of the steel divided by the area of the steel, and the elasticity of the steel. Now, since this column has a length for the concrete and the steel that are equal, therefore, the length of your concrete and the length of the steel will cancel out because they're equal. You now have an equation which is force of the concrete divided by the area of the concrete. What's the area of the concrete? The area of the concrete is equivalent to the whole rectangle, which is 450 by 400, but you have to subtract the steel bars because they are not concrete. You have 6 times pi 25 squared divided by 4, so that's an area of a circle, and you have an area of concrete equivalent to 177,054.76 millimeter squared. So you are dividing this one with 177,054.76. The elasticity of concrete is 15, and that's equivalent to the force of your steel divided by the area of the steel. So 6 times pi 25 squared divided by 4 is equivalent to 2,945.24. You multiply this by 200 gigapascal, that is the elasticity of steel. So simplifying this equation, you would have force carried by your concrete is equivalent to 4.51 of the force carried by your steel. Now, this is your equation number 2. Taken from your elastic deformation. So, remember, your equation number 1 is force of the steel, goes up, supporting 350, and also PC, force of the concrete, that is also supporting 350. So they are both combined, and it is equivalent to 350. So if you're going to substitute, this equation, this particular equation here, equation number 1 to equation number 2, you would therefore have you have PC, force of the concrete plus force of the steel equivalent to 350. So previously you were able to solve for the force of the concrete as 4.51 the force of your steel, okay, taken from your elastic deformation equation is equivalent now to 350. So if you're going to simplify this, you have the force of your steel is equivalent to 63.52 kilonewtons. So substituting it here, since you already got the force of the steel as 63.52, you will also get the force of the concrete equivalent to 286.48 kilonewtons. Okay, so your final answer for the stress in steel is the force of the steel all over the area of the steel. That was in chapter 1. And force of the steel is 63,520 transforming kilonewton to newtons divided by its area, and we were able to previously solve the area as 2,945.24 millimeters squared. That is for 625 millimeter diameter. It gives you an answer of 21.57 megapascal. So they are being compressed, so it's a compressive stress. The stress for concrete is also the same thing. Force of the concrete divided by the area of the concrete gives you a value of 286,480 newtons, okay, from kilonewtons divided by the area of 177,054.76 millimeter squared. Gives you an answer of 1.62. So Newton per millimeter squared is megapascal. So I hope you understood how to solve the first problem combining equation of equilibrium, which is summation of force vertical, together with the elastic deformation. Thank you very much.